There is a moon orbiting Saturn that has been confusing scientists for 70 years. Not because it is featureless, not because it is simple, but because, from everything the instruments say, it should not be this interesting. And yet every probe, every flyby, every data transmission from every spacecraft that has ever visited it has come back with the same impossible message. Titan looks like Earth. Not in any way you would recognize from orbit. It is not blue and green. It does not have forests or ice caps or the familiar continental shapes that tell you immediately that you are looking at home. It is amber, a deep, warm, hazy amber, a global smog layer so thick that from space, Titan looks like a featureless orange ball, its surface completely hidden from visible light by a permanent photochemical haze that extends 600 kilometers above the ground.
But beneath that haze, beneath the orange ceiling and the nitrogen atmosphere that is, by percentage composition, the closest to Earth's atmosphere of any world in the solar system, there is a landscape that is familiar in all the wrong ways. There are rivers, there are lakes, there are seas, there are coastlines and deltas and erosion patterns that look, in the radar maps assembled by the Cassini spacecraft over 13 years of orbits, almost exactly like the coastlines and deltas and erosion patterns of Earth. The rivers and lakes and seas of Titan are not water, they are methane, liquid methane. At a surface temperature of minus 179 degrees Celsius, cold enough that water is not a liquid here, not even close, water here is a rock. Methane has taken water's role in the hydrological cycle. Methane evaporates. Methane forms clouds. Methane rains from the sky. Methane flows in rivers to the methane seas and sits there, patient and amber dark, waiting for the season to change. Titan has seasons. They last 7 Earth years each. Titan has weather. It has wind. It has dunes. Vast equatorial sand dunes made not of silica, but of complex organic molecules, shaped by Titan's slow winds into ridges that stretch for hundreds of kilometers. And in the northern hemisphere, right now, it is late summer, which means Kraken Mare, the largest methane sea on Titan, roughly the size of the Caspian Sea on Earth, is at its fullest. Its surface is calm. Its shores are lined with organic sediment. Its depth reaches 300 meters in places. No human instrument has ever touched its surface. The Aegis has been reconfigured for cold, extreme cold. The thermal systems that were stripped out for the quantum drop and rebuilt for the neutron star have been redesigned again, not to keep heat out, but to keep it in. The suit's thermal core is running at full output. The surface temperature on Titan will pull heat from your suit with patient, absolute efficiency, and the suit must answer that pull with everything it has, continuously, without rest. The atmospheric entry system has been recalculated. Titan's atmosphere is thick, thicker at the surface than Earth's, which means entry is slow, and the descent through the haze layers will take time. Time enough to see what lives in the sky before you reach what lives below. Could you survive descending into Titan's atmosphere? Entry begins at 1,200 kilometers altitude. At this height, Titan's atmosphere is thinner than the stratosphere of Earth, but it is present. It registers on the suit's pressure sensors as the first faint whisper of a world that has air. Real air.
the densest, most substantial atmosphere of any moon in the solar system. It is mostly nitrogen, 95% nitrogen, almost exactly the same percentage as Earth's atmosphere. The remaining 5% is mostly methane, with trace amounts of hydrogen and a zoo of organic molecules: ethane, propylene, acetylene, benzene, hydrogen cyanide, that form in the upper atmosphere when sunlight breaks methane apart and the fragments recombine into increasingly complex chemistry. That chemistry is the reason Titan is amber. The haze particles, tiny complex organic molecules called tholins, are being created right now around your suit at this altitude. The sunlight hitting Titan's upper atmosphere is running a continuous chemical factory, assembling organic molecules from simple precursors, letting them drift downward, accumulating on every surface below. The dunes at Titan's equator are made of tholins. The sediment at the bottom of Kraken Mare is made of tholins. The orange haze that makes Titan look featureless from space is tholins. Tholins are interesting for a specific reason that the mission briefing spent considerable time on. When tholins are exposed to liquid water, even briefly, even in small amounts, they spontaneously produce amino acids, the building blocks of proteins, the building blocks of life as life on Earth runs it. Titan has no liquid water, but it has liquid methane. And the question, one of the most argued questions in astrobiology, is whether a different solvent could support a different biochemistry. Whether something could live in liquid methane the way Earth life lives in liquid water. Whether the organic chemistry raining down from Titan's sky into Titan's seas could, given enough time and the right conditions, organize itself into something that eats and grows and reproduces. Titan has had 4 billion years. You descend into the haze at 500 kilometers altitude. The amber deepens. The haze particles are thick enough now to scatter and absorb the sunlight, turning the sky a deeper and deeper orange. Below you, nothing is visible. The surface is hidden under this ceiling. The haze is not a cloud. There is no distinct upper boundary you pass through, no moment where visibility suddenly drops. It is a gradient. Slowly, patiently, the orange gets thicker, the horizon gets closer, the sunlight gets more diffuse, until you realize, sometime around 200 kilometers altitude, that you can no longer tell where the sky ends and the world begins. You are inside the amber. At 80 kilometers altitude, the haze thins briefly, not to transparency, but to a texture. A structure becomes visible in the orange. You are looking at Titan's troposphere, and the troposphere has weather. The clouds are made of methane. At this temperature and pressure, methane condenses into droplets at specific altitude bands, forming cloud layers that are, visually, almost identical to Earth's cumulus clouds, white, rounded, vertically developed, except that they are tinted amber by the haze above them, and they are made of a cryogenic hydrocarbon, and the rain they drop is cold enough to freeze carbon dioxide solid. Below one cloud system, a large convective cell easily 300 kilometers across, its radar signatures suggesting active methane precipitation, the suit's sensors detect a downdraft. Rain. Methane rain, falling through the orange air, making a weather system that functions with all the logic of an Earth thunderstorm, obeying the same fluid dynamics and thermodynamics and convective physics,
but in a chemistry so foreign that every molecule falling from that cloud would be toxic to every biochemistry on Earth. You fly through the edge of the system. Methane droplets hit your visor. They are not water. The surface tension is different. They spread and run differently. The beads smaller, the flow slower. The way they catch the amber light slightly different from rain on any terrestrial surface. You watch them run down your visor for a moment before the suit's thermal gradient evaporates them. It rained on your helmet. On Saturn's largest moon, in a chemistry that has no name in any human language for weather, it rained on your helmet. At 40 kilometers altitude, the surface begins to be visible through the haze. Not invisible light. The amber is still too thick for that. But your suit's radar is painting a picture. A vast, flat plain to the north, darker than the surrounding terrain, with a complex shoreline visible at its southern edge. Kraken Mare. You are looking at the largest liquid sea on any body in the solar system other than Earth, and it is made of methane. You begin your final descent. The surface of Titan is not what you expected. You expected alien. You expected inhospitable. You expected the landscape of another world, communicating its foreignness in every detail. Titan communicates something more unsettling than foreignness. It communicates familiarity. You land on the shore of Kraken Mare, at the edge of a gently sloping beach. The ground is firm, packed organic sediment, tholins deposited over billions of years and compressed into something that has the texture, under your boots, of damp sand. The shore curves away in both directions, following a coastline that the Cassini radar maps showed you before descent, and the reality matches the maps with unnerving precision. The sea is in front of you. It is not blue. It is not the gray-green of the North Atlantic or the deep turquoise of the Pacific. It is dark amber, almost black in the center where it is deepest, lightening toward the shallow edges where the bottom is visible. Its surface is nearly calm. Small ripples, driven by winds so faint that on Earth they would be considered still air, cross the surface in slow patterns. There is a horizon, a real horizon, at the edge of the sea where the liquid meets the amber sky. The sun is visible above the horizon as a pale disk, 4 times smaller than it appears from Earth, 90 times dimmer, but present. Actual sunlight, reaching this surface through 600 kilometers of organic haze, reduced to something like a dim winter afternoon on Earth. Enough to see by, enough for the cameras to work without artificial light. You walk to the edge of the liquid. The methane laps at the shore. It laps. The same motion that water makes at the edge of a lake on Earth, driven by the same physics of surface tension and wave dynamics, but in a liquid with different density, different viscosity, a different speed of sound, a different response to the light that falls on it. You stand at the edge of an alien sea and watch it move. And the movement is familiar, and that is the most frightening thing you have encountered in this entire program. Not the acid of Venus, not the ice artillery of Saturn's rings, not the quantum foam at the bottom of reality. The way the methane laps at the shore, the suit's chemical sensors are running at maximum sensitivity. The water of Titan, the methane, the liquid that fills these seas and falls from these skies and runs in these rivers, is not pure. It is a complex mixture, liquid methane and ethane, with dissolved nitrogen and organic molecules, and tholins washing in from the surrounding terrain. The chemistry is rich. It is not random. It has structure. The sensors are looking for specific signatures. On Earth, life in water is detectable by what it consumes and what it produces. Photosynthetic life consumes CO2 and produces oxygen. Chemosynthetic life consumes hydrogen sulfide and produces sulfur. Life, at the most fundamental level, is a chemical imbalance, a persistent, organized departure from the chemistry that thermodynamics alone would produce.
In Titan's methane seas, the predicted signature of methane-based life, if it exists, is a depletion of hydrogen near the surface, combined with an anomalous concentration of acetylene at the sea floor. Life using methane as a solvent, breathing hydrogen, metabolizing acetylene as an energy source. Not our biochemistry, a different solution to the same problem. The sensors are looking for that depletion. The results are ambiguous. Hydrogen is present at lower concentrations than purely abiotic models predict. Not absent, not dramatically depleted. Lower. The difference is within the range that geological processes could explain. It is within the range that measurement uncertainty could explain. It is also within the range that a sparse population of methane-based microorganisms could explain. The acetylene data is similarly ambiguous. Lower at depth than models predict. Not absent, lower. 3 data points in the history of Titan studies have suggested this pattern.
3 data points is not a conclusion, it is a suggestion. It is a question asked in the language of chemistry to which the universe has not yet given a clear answer. You stand on the shore and watch the dark sea and hold the ambiguity. Somewhere in that amber dark, in 300 meters of liquid methane over a floor of organic sediment, under a sky of organic haze, on a moon that has been running this chemistry for 4 billion years, there may be something alive. Not alive the way you are alive. Not alive the way the bacteria in Europa's ocean may be alive. Something that has never touched water, that has no protein, no DNA, no phospholipid membrane. Something built from a completely different molecular vocabulary, solving the same thermodynamic problem by completely different means. Or there is nothing. The ambiguity does not resolve. You watch the sea. You travel south, away from Kraken Mare, toward the equatorial dune fields. They begin gradually, first as low ripples in the organic sediment, then as distinct ridges, then within 100 kilometers of the shore as the full Titan dune landscape. Parallel ridges of dark organic material, each one up to 150 meters tall, stretching east to west in lines so regular they look engineered. They are not engineered. They are shaped by Titan's eastward winds, winds that blow at 1 to 2 meters per second on average, barely a breeze, but that have been blowing for hundreds of millions of years. At those timescales, a breeze is enough. The dune material, tholins, complex organics fallen from the sky for billions of years, is soft under your boots. It has the texture of fine ash. Each grain is an organic molecule, assembled in the upper atmosphere from methane and nitrogen and sunlight. fallen through 600 kilometers of amber sky, landed here, been blown east by the slow wind, been incorporated into a dune that grows by millimeters per year and has been growing for geological time. Every grain of this sand fell from the sky. You climbed the nearest dune, 150 meters of fine organic material, the slope gentle, the footing uncertain in the low gravity, which is only 14% of Earth's. At the crest, you stop. The view is extraordinary. To the north, the amber haze above Kraken Mare, the horizon darker where the sea begins, the slight sheen of reflected skylight off the methane surface. To the south, dune field after dune field after dune field, stretching to the horizon and beyond, each ridge parallel to the last, each one casting a long shadow in the diffuse amber light. Above, the orange sky, uniform and total. The sun, a pale disk just above the western horizon. Saturn, not visible, blocked by the very atmosphere that makes this world habitable. Around you, the silence of a world where the wind is too faint to hear, where there are no animals, where the only sounds are the suit's systems and the faint creak of organic sediment settling under your weight. This is what 4 billion years of chemistry without biology looks like. Or, this is what 4 billion years of chemistry with a biology you cannot detect looks like. The dune does not tell you which. It begins on the ascent. The convective methane system you passed through on the way down has tracked south, following the temperature gradients of the landscape. And it has found you on the dune field. The methane rain falls in Titan's gravity at 0.14 g. It falls slowly, each drop a small amber-tinted sphere, descending at a fraction of the speed Earth rain falls. It is, visually, the most surreal precipitation in the solar system. Slow, large-dropped, amber-tinted, falling from an orange sky onto orange dunes, pooling briefly in the troughs between ridges before the dune sediment absorbs it. You stand in it. The drops hit your visor and your suit and run down in slow rivulets, the liquid methane finding the low points of every surface, following gravity with perfect chemical indifference. Your suit's thermal systems note the additional cooling load and compensate. It is raining methane on you, on an alien moon 1.2 billion kilometers from Earth, and the rain behaves like rain. It falls the way rain falls. It pools the way rain pools. It runs the way rain runs. The same physics, a different universe. You begin your ascent through the amber atmosphere, slowly, the thick air requiring sustained thrust, the haze closing in above you as you climb, the surface receding through the orange until it disappears, and there is only the gradient of amber around you and the pale disk of the sun growing clearer as you rise. At 200 kilometers, the haze is thinner. The stars appear, faint but present, the familiar constellations of deep space visible through the organic smog of a moon that has been building its atmosphere from the raw materials of chemistry for 4 billion years. Behind you, Titan, amber, featureless from this altitude, hiding its rivers and dunes and methane seas and ambiguous chemistry and 4 billion years of patient, solar-powered molecular assembly behind a curtain of organic haze. Below that haze, a shore. A sea that laps like water and is not water. A rain that falls like rain and is not rain. A chemistry that looks, at every scale, like it is doing something, and may be doing nothing more than following the thermodynamic gradient from sunlight to darkness, assembling molecules and disassembling them, running the chemistry without ever achieving biology. Or may, in the troughs between those dunes, in the floor sediment of Kraken Mare, in the hydrogen-depleted interface between sea and sky, have crossed the line. 4 billion years is a long time to run any experiment. The result is ambiguous. The universe does not resolve ambiguity on request. Could you survive descending into Titan's atmosphere? Your biology survived. Your suit managed the cold. The amber chemistry kept its secrets. But here is what you carry back, and it is heavier than data. Every previous mission in this program took you somewhere that was trying, in one way or another, to kill you. Saturn's rings with their ice artillery. Venus with its acid and heat. The neutron star with its gravity and radiation, and the physics that ends at its core. Europa with its ice and pressure, and the ocean that may or may not be inhabited. Titan is the first environment in this program that felt like it was waiting for you to arrive. Not hostile, not welcoming. Something between. The way an empty house feels when you find evidence that someone recently lived there and left in a hurry. The chemistry is familiar. The geography is familiar. The weather is familiar. The organic molecules raining from the sky are the raw materials of life as we know it, in a solvent that may support life as we don't. Maybe that familiarity is physics, the same laws operating in a different solvent, producing similar large-scale structures by necessity rather than design. Maybe it is something else. Titan does not say. What impossible environment should we face next? Should we fall to the absolute center of the Earth, straight through 6,371 kilometers of mantle and iron crystal and liquid metal, becoming a human pendulum swinging through the planet's core forever? Or should we enter the Boötes void, 330 million light-years of the universe's largest near emptiness, where no galaxy has a right to be absent, and science has spent 40 years not knowing why? Vote in the comments below, and subscribe to Could You before the methane season changes.